2008 Canadian Open Mathematics Challenge Part A. If 2x plus y is 13, x plus 2y is 11, what is the value of x plus y? 2x plus y is 13 and x plus 2y is 11. So just add these two, and that's 3x plus 3y is equal to 24. Factor out the 3, and when you do, you get 3 times x plus y. And that is equal to 24. And then just divide through by 3, and you get x plus y is 24 divided by 3, and that is, of course, equal to 8. Determine the units digit of the integer equal to 9 plus 9 squared plus 9 to the power 3 plus 9 to the power of 4. The units digit of an integer is its rightmost digit. For example, the units digit of the integer 1, 2, 3, 4 is 4. Okay, so I guess we'll just do this manually. I don't see any other tricks. If there are, I don't really feel they're necessary. This is 9, this is 81. 9 to the power of 3 is 729. 9 to the power of 4 is 6561. Add these all up and you do 7380. The units digit is the rightmost digit, which in this case is 0. If the average of 4 different positive integers is 8, what is the largest possible value of any one of these integers? We have 4 different positive integers, so I'll call them A, B, C, and D. And their average is 8. All right, so that's basically the equation. Multiply through by 4, and you get A plus B plus C plus D is equal to 32. Now they're saying, what is the largest possible? So let's just say that our D is the largest of these 4. To make D the largest, we would have to make A, B, and C the smallest, correct? So we want to make these as small as possible. And keep in mind that they're different. So the smallest positive integer is 1. Now I can't make B 1 because all the integers have to be different. So I'll make it 2. That's the next smallest. The next smallest for C would be 3. And then I've got my D in here. So that equals 32. So this is 6 plus D is 32. And therefore D is 32 minus 6, which is 26. And 26 is therefore the largest possible value of any one of these integers if their average is 8. In the diagram, D is on AB and E is on AC. And DE is parallel to BC. Also, DE is equal to 1, BC is 6, AE is x, and EC is x squared plus 4. Determine all possible values of x. We have a similar triangle situation. Triangle ADE is similar to triangle ABC. And that's pretty obvious in this question. All the angles are the same. So based on that, the ratio of the sides would be the same. So x over 1 would be the equivalent of this side over this side. So that whole side would be x plus x squared plus 4. And the bottom is 6. So there you go. That's the equation that we'd have to solve. Cross multiply and you get 6x is equal to x plus x squared plus 4. Let's put everything on one side. X squared minus 5x plus 4 is equal to 0. And then if we factor this, x, 4, 4, 1, 1, negative, negative, and therefore x is equal to 4 or 1. Four consecutive integers p, q, r, s with p less than q less than r less than s satisfy half p plus a third q plus a quarter r is equal to s. What is the value of s? All right, so they're consecutive, right? So p, q, r, and s, if they're consecutive, it would be like n, n plus 1, n plus 2, n plus 3. All right, so then I guess we just have to sub it into that equation. So that equation is p over 2 plus q over 3 plus r over 4 is equal to s. All right, let's substitute these values. So let's see here. N over 2 plus n plus 1 over 3 plus n plus 2 over 4, and that is equal to n plus 3. Let's get rid of the fraction, and I can do that by multiplying through by 12 on both sides. And if I do, I will get 6n plus 4n plus 4, and then 3n plus 6, and then over here, 12n plus 36. Okay, add these all up. Let's see here, 13n, 12n, so I get 13n minus 12n over here, and then the numbers are 36 minus 10, right? Yeah, 36 minus 10. So this is just n, and this is 26. Okay, what do they want? The value of s. Okay, well, s is n plus 3, so that means s is equal to n plus 3. N is 26, so 26 plus 3, and therefore s is equal to 29. Rectangle ABCD intersects a circle at points E, F, G, and H as shown. If AH is 4 and HG is 5 and BE is 3, determine the length of EF. All right. Let's see here. I'm going to draw a line from the center of the circle to, where should I draw? To H, I think. That should be good. And I'll probably do the same thing again from the center to G. And do I need any more lines here? I'm not really sure. I'll just draw them in. If I don't need them, I don't use them. I'll draw one line that goes straight, sort of top to bottom like that. Okay. And I think that should be it. Yeah. Okay. So let's see if I can explain this. All right. So AH is 4. So from there to there, they're saying is 4. And then HG from there to there is 5. Okay. So this whole thing is 5. But the problem, though, is that we don't really care about HG. We just care about H to that midpoint, right? Because this is a symmetric diagram. The way I drew the diagram, it's symmetric on both sides. So this is equal to this. So that means this distance from here to here, this distance from there to there, is half of 5. So it'd be 2.5. So let me squeeze that in there, 2.5. From here to there. And then BE, they tell me, is 3. So that's 3. Okay. Well, I can calculate this distance now. And then EF would just be double that because it's symmetric on both sides. That distance can be calculated because from here to here is the equivalent of from there to there because it's a rectangle. And this line, the way I drew it, is perpendicular. Like that. So that means this 4 plus that 2.5 is equal to 3 plus, from here to here, we'll just call it x, I guess. Plus x. Okay, that should be good enough. So this is, what, 6.5 minus 3 is equal to x, and therefore x is 3.5. Now, EF, which is what they want us to figure out, is actually 2x, because this is also going to be x. So 2x, and since x is 3.5, we have EF equal to 7. A star is placed in the bottom right corner square of a 3x3 grid as shown. A fair coin is flipped repeatedly. Each time that coin shows heads, a star is moved one space upward. Each time that coin shows tails, the star is moved one space to the left. The star may move off the grid. Determine the probability that the star reaches the top left corner of the grid. Heads means that you move up. Tails means you move left. So here's a star, that's where it starts. And in order to get up here, which is the top left corner, we have to go left twice. So we have to go L, L, and then we have to go up twice. Regardless of orientation, like it doesn't have to be L, L, up, up. As long as there's 2 L's and 2 ups, it could be 1 L this way, 1 up, up, and then 2 L's, sorry, 1 L that way. So in any combination, we have to have at least 2 L's and 2 ups. So 2 L's and 2 ups really just mean 2 H's and 2 tails. So we have to figure out how many ways are there to get 2 H's and 2 tails if you flip the coin 4 times. So the probability is always a fraction. The denominator is the total number of possibilities. So if you flip a coin once, there's 2 possibilities, right? Heads or tails. If you flip a coin again, there's 2 possibilities. And if you flip the coin 3rd time, again, same thing. And if you flip the coin 4th time, again. So if you flip a coin 4 times, the number of different possibilities is 2 times 2 times 2 times 2. So that's 2 to the power 4. That's the total. That's what goes in the denominator. But what goes in the numerator is our specific condition. And in our case, our specific condition is that we must have 2 heads and 2 tails. Okay. I don't think that should be that hard. Use choose notation. From the 4 flips, this is the first flip, second flip, third flip, fourth flip, we want to choose 2 to be heads. And then from the remaining 2 flips of the coin, we want both of those to be tails. And that's it. That's how you would figure it out. Now, just in case you don't like choose notation, you can do it manually. And there's not that many possibilities. H, H, T, T, that's 1. H, T, H, T. H, T, T, H. This is basically how to get 2 H's and 2 tails if you flip the coin 4 times. T, H, H, T, T, H, T, H, and T, T, H, H. So, as you can see, it's just 6. Interestingly, 4 choose 2 is also 6. It's 4 factorial over 4 minus 2 factorial over 2 factorial. And 2 choose 2 is just 1. And then 2 to the power of 4 is 16. And therefore that would be 4 times 3 divided by 2, which is 6. So 6 over 16. And of course, in lowest terms, that's 3 over 8. And that is the probability that they want you to figure out. Determine the sum of all integer values of the parameter r for which the equation x to the power of 3 minus rx plus r plus 11 is equal to 0. Has at least one positive integer solution for x. Okay, so let's isolate for one variable, and I will isolate for r, since that's the one we're interested in. Yeah, and r has to be an integer, right? Yeah, integer values. Okay, so I guess we have to figure out integer values once we isolate. All right, so let's do that. First, put all the r's on one side. So this is going to be rx minus r. And on this side, we still have just this x to the power of 3 plus 11. Factor out the r, you get x minus 1. X to the power of 3 plus 11. X to the power of 3 plus 11 over x minus 1 is equal to r. Okay, great. So this has to be an integer. And now we have to do a little bit of what I call fancy algebra. And if you've done a lot of these questions, it will sort of become easier for you. It might seem a little like trickery if you're not used to it. But if you get used to it, you should be able to do it without too much problem. So the x to the power of 3 plus 11, we can break up into minus 1 plus 12. And then that will help us factor this. Therefore, it becomes x to the power of 3 minus 1 over x minus 1. And then this is just going to be 12 over x minus 1 like that. The x to the power of 3 minus 1, that factors into x minus 1 times x squared plus x plus 1. And that's over x minus 1. And then we just have this 12 over x minus 1. And that is all equal to r. Okay, well, that cancels with that. So this is just going to be x squared plus x plus 1. And then this is 12 over x minus 1. So there we go. So a little bit of fancy algebra. We got it down to this stage. Now, no matter what x is, no matter what integer x is, see, x is a positive integer, right? This part will remain an integer, so we don't have to worry about that. But in order for r to be an integer, this has to be an integer also. So we have to figure out what values of x make that an integer. So we've got to make a little table here. So we got x minus 1, and then what is x, and then what is r, which is x squared plus x plus 1 plus 12 over x minus 1. Okay, so here we go. Well, obviously, x minus 1 has to be divisible by 12, so it's got to be either 12. It's got to be, you have to be able to divide it into 12. So either 6, 4, 3, 2, or 1. Correct? And that would make this an integer, and therefore r would become an integer because x is an integer. X values would be 13, 7, 5, 4, 3, 2, 1. And then when you sub these values of x into that big long equation, I'll let you do that. You get 184, 59, 34, 25, 19, and 19. So what is the question asking? They want you to the sum of all integer values of the parameter r. The sum of all integer values of the parameter r. These are the integer values of the parameter r. But this question's a bit tricky because they really should put the word unique, the sum of all unique integer values for the parameter r, because they don't want you to count this 19 more than once. They only want you to count the unique values of r. They don't say that, and I guess they assume that you would know, but I think they really should have put that word unique. So you add up these guys only. You only add the 19 once, and when you do, you get 321. And that is the answer to the question.